In this lesson, we're going to use equations of parallel lines and perpendicular lines to solve some problems, to do some, partition or break a segment into ratios of a specified amount, into any amount that we want, really. We'll also use the slope of a line to find coordinates, and to determine if lines are parallel and perpendicular. We've already done, we've looked at determining if lines are parallel and perpendicular as part of our review at the beginning of the unit, but we'll revisit that and expand on that. Just as a reminder, what do lines of various slopes look like? Negative slopes go down from left to right. So I'm just going to draw a picture. Down from left to right. Positive slopes go up, up, from left to right. Zero slope and undefined slope. We say that a line has zero slope if it's horizontal. Meaning the output, or the y, does not change as x gets bigger and smaller. An undefined slope means the x doesn't change as y goes up and down, or there's only one input. Okay. And just as a reminder, in coordinates, here's a classic formula for calculating slope. We're going to be using slopes in order to do all of our analyzing and solve all of these problems in all of these ways. So it's important you know how to, and remember how to calculate that and use those. We'll start here with just calculating some slopes just to get our feet underneath of us, and then we'll do some maybe a little more interesting calculations here. So let's just find the slopes of these lines. Find the slope of line B. I'm always going to try to use points that are on the grid lines that are more or less shown to us. Also note that this is a, in this diagram, this is the x-axis. It's not this one that's going through the middle of the piece of graph here. Here's the y-axis. And I know that because the 1 and 1, if I'm 1 unit over from to the right and up, that means this got to be 0, 0. Okay. Anyways, let's identify what some of these points are. I think this is over 0, up 1. This other point that's labeled must be over 1, 2, over 3, and up 1, 2, 3, 4, 5, 6, 7. The slope of line B then should be change in y over change in x. To go from 0,1 to 3,7, y changes by 6, goes up 6, and it goes to the right 3, or if you subtract 3 from 0, 3. Just write as, you could leave the slope as 2 over 1 or just 2. I think 2 over 1 usually is more useful for identifying rise and run, but 2 is fine as well. What's the slope of line C? Line C is a horizontal line. It's 0. You can see that if you want to check with coordinates to make sure that that makes sense. It looks like this coordinate is 2, 3, and this coordinate is minus 3, 3, and 3 minus 3 over 3 minus minus 3 is 0 over 6, which is 0.